Welcome students to Properties of Logarithms, which is on page 4 of your notes. So we are going to be looking at rules that can either take multiple logs and combine them into one, or rules that take a single log and split it up into its different parts. Now if you look at the names of the rules, product rule, quotient rule, power rule, so multiplication, division, and exponents, those are basically PEMDAS steps. So when you're expanding, meaning when you're taking a single log and splitting it up into multiple parts, you are going to do first product and quotient rule and then power rule. So you're basically doing reverse PEMDAS here. When you're taking multiple logs and combining them into one log, you are going to go this direction. So power first and then then product and quotient, which is PEMDAS. So you would want to use this when solving equations in which there are multiple logs, and we want this to be your first step, to take them and combine them into just a single one. So we're just going to jump into some examples so that I can show you how this works. So simplify each expression. So we're going to be using this set of rules. So this is the kind of thing you might see. In fact, some of you have probably already looked at this assignment. When you're solving equations that have multiple logs in them, you want to do this. So I have on number 1 log base 2 of x plus log base 2 of y. And I want to combine that into just a single log. I just want one log, not two. So when I'm adding logs together, so match this, when I'm adding logs together, I take their arguments and multiply them together. So basically, adding logs turns into multiplying the arguments. So adding logs turns into multiplying the arguments. So I'm just going to, oh hey, that's exactly the same problem. Check that out. I'm adding logs, so I'm going to multiply the arguments. So x times y. So there is my log combined into a single one, and that's it. That's the answer. You're not going to get a single number or anything. You're just simplifying what you have. On the other hand, if you are subtracting two logs, that's this rule right here. So subtracting two logs means you are going to divide the arguments. So you're going to take, notice we have x, and then we're going to divide by the second one. So x divided by y. So that's kind of like this one here. Log base 2. And so 4 is kind of like my x right here, and 5 is kind of like my y right there. So notice I'm going to take the first one divided by the second one. So the first one divided by the second one. And this one you could simplify further. You could put that in your calculator and get a final answer, but right now we're not going to. Just kind of, so you're going to divide those. Okay, now this is your power rule. So that says if I've got a coefficient in front of the log, I can actually turn that into an exponent right here. So let me highlight. So this little guy, this little coefficient, becomes the power of the argument. So that's like this. This 2 becomes a power right there. So that gives me log base, oops, that was base 3. I wasn't even paying attention. Sorry, make that a 3. So log base 3 of x and then squared. And that is how you simplify those. So we're going to do 6 together. And I'm going to let you guys try 4, 5, and 7. So this one's a little bit more complex just because we got multiple things going on. Notice I have a subtraction here. So I'm going to be using this rule. And I have a coefficient in front. So I've got this 5 in front, which means I'm going to be using power rule. And this arrow tells me I need to start with power rule and then do these two. So let's do that first. So this guy, the 5, is going to go there. So that gives me log base 3 of 4x minus log base 3 of y to the 5th power. So I got my power rule done. Then I'm going to go to do quotient or product rule, and I have a quotient rule here. So that means I'm going to take these guys here and divide them. So that gives me log base 3, and then the first one, so the first one goes on top, the second one goes on bottom. So the first one goes on top, the second one goes on the bottom. And there is my simplified expression right there. So I'm gonna pause the video so that you can try these yourself. See what you can do. All right, so for number 4, notice we are adding 2 logs together that have the same base, which means we are going to multiply their arguments. So we're using that product rule. When you add together 2 logs, you can multiply their arguments. So that's what I'm doing here. I am taking log base 3 and then 2 times x. And that gives me my simplified expression. Now number 5, notice there's a subtraction here. So I'm going to go to my rule. So when I subtract 2 logs, I can combine them by dividing their arguments. So I'm going to put the first one over the second one. So when I'm subtracting these 2 log base 4, I am going to take 16 over x as my argument. And I swear that's an x. And there's my simplified expression. On the final one, I have 2 different rules in use. So I noticed I had this 4 in front, which could become an exponent. And since I have to go this direction, I'm going to use my power rule first. So I'm going to take that number in front and make it an exponent. So I get log base 10 of x to the 4th power, and then plus log base 10 of 3y. And then this plus tells me I can use product rule to combine the arguments. So I'm going to use product rule to combine the arguments by multiplying them. So that gives me log base 10 of x to the 4th times 3y. And some people will like to simplify that even more by putting it in this order. It doesn't really matter. You're usually going to see it written like this, like the numbers first, then x and y, because it's alphabetical that way, but it has the same value, so it's fine either way. Okay. Now we're going to go back the other way. So we're doing this kind of the same thing here, but instead of having a single log, we're now splitting it apart. So now we're going to use these rules. So we're using the expanding rules now. And this you're not going to use as often, at least in this class. But let's practice a little bit. Hope you'll learn to recognize the rules anyway. So let's check out number 8. So I have log of AB. Now remember, AB means A times B. So this really says log of A times B. So let's see which rule that is. So go up here. Remember, we're on the expand side. So log of x times y, we're going to take x and y and split them up. So notice when I multiply the arguments, that's the same as adding the 2 logs together. So it's doing the same thing as this rule, just backwards. So notice that's just backwards. So we're just going the other direction now. So I'm going to take my 2 factors and split them up into different logs like this, connected by a plus. So I'm going to take log of A and then split that up into a separate log, so plus log of B. And then there's nothing else I can split up there, so I'm done. All done. Just like that. Okay, let's try number 9. So number 9, I see actually several things going on here. There's multiplication here, and then there's division right there. So this is actually going to have 3 parts when we're done. It's going to have log of 3 is going to be a separate part. Log of x is going to be a separate part. And log of y is going to be a separate part. So those colors look almost the same, don't they? That just made it worse, didn't it? Well, I tried. Let me rewrite that a little bit bigger. So that used to say log of 3x over y. Okay, so first let's go ahead and use the quotient rule. So this division here means I can take the argument and just split it up each into its own log. So the top is going to be first, and then the bottom is going to be second, and you're going to subtract it. So I'm going to write log of 3x minus log of y. So log of the top minus log of the bottom. And then this one, remember that's really a times sign, so that's really 3 times x. So then I can split this one up just like I split this one up. So it's kind of the same thing. Like this is your a and that's your b. So log of 3 plus log of x, and then minus log of y. So that's that one. Alrighty, number 10. So this is a much simpler one. So check that out. I've got log base 5 of x squared. So that little squared is a power. So let's check that out. A power, there it is. So notice I'm going to be taking that exponent and bringing it out in front. Just like here, except the other way. So instead of here to here, we're just going backwards. So I'm going to take that power and bring it out in front right there. So that gives me 2 times log base 5 of x. And I'm done. That's simplified. Alrighty. Okay. Let's try 14, and then I'm going to leave 11, 12, and 13 for you. Okay, so 14, notice I've got powers, and I've got, actually there's a multiplication in there too. So let's look at our 2 expand rules and see which one we need to do first. So remember, I've got power and I've got multiplication. So since my arrow is going this way, that means I need to do the product rule first, or quotient rule if I had one, and then power rule at the end. So we're first going to split up this multiplication into an addition of 2 logs. So I'm going to take the x to the third. I'm going to separate the x to the third and the y to the 7th. And then I'll do the exponents at the end. So log base 2 of x to the third plus log base 2 of y to the 7th. And then I've got power rule. So I've got a situation like this. So I'm going to just take the power or the exponent and bring it out in front. So this is going to be 3 log base 2 of x plus 7 log base 2 of y. And then that one is done. So try 11, 12, and 13. See if you can get them right. And on the assignment, I will likely definitely have small group for this assignment afterwards. So, but try 11, 12, and 13. So on 11, you should have gotten log of 3 plus log of y. So you're using product rule, which means you take the two factors in the argument and split them up with addition. So you're using that rule right there. Take the two factors in the argument and split them up with addition. And then 12. So that's kind of like number 9. You've got product on top and then the quotient. So separate the numerator and denominator by subtracting the logs. And then separate these two factors just like you did on 11 by adding the logs together. So you should end up with log of 7 plus log of y minus log of x. And finally on 13, you have a usage of power rule. So this one, which means you can take the power and bring it out in front of the log, which I've done here. So you have 4 times log of y. And that's done. Finished.